Okay, geometry, we've got a short chapter 9 review today. I think there's like 15 questions on this review. And then we will test over chapter 9 tomorrow and start our last chapter, chapter 10. So, chapter 9, number 1, they've got two circles that are intersecting, and we've got, they give us diameters of each, okay? Now, keep in mind diameter goes all the way across, so we're going to want to use that value to find the radius. The diameter of circle A is 10. So that means all the way across circle A from here to here, that would be 10. So then 5 is going to be just from here to here, or from here to here, 5 and 5, okay? Then we have circle B is 8 inches, and that's the diameter again. So that means all the way across circle B from there to there would be 8. So from here to here is 4, and from here to here is 4. Okay, then they're going to give me one other piece of information, and it is that AX is 3. So from here to here, this little bit is 3, and they're wanting me to find YB. Okay, YB is this little bit right here. Okay, so we kind of have to map this through. If this is 3, then this would have to be 2 in order for them to add up to be 5. And if this is 2, then this would also have to be 2 in order for those to add up to be 4. Okay, so just kind of a lot of mapping to do, but YB is going to be 2 inches. That's how big that little chunk is. So going through, just map it out, make sure you have nice, decent handwriting to do that, and there you go. Okay, number 2 says find M, and this means the measure of GH, okay, and that's going to be in degrees. So they want to know the measure of from G to H, this little bit right here. Okay, so the only thing that they label for me is that this is a 90-degree angle. So this angle right here is 90, and then this little bit right here is 20. Okay, I don't know if you can see that labeling there, but one thing that I see is that this line goes all the way through the circle, which means that these all add up to be 180. Okay, so if I have a 20 here and a 90 here, that will give me the rest of the way. So 20 and 90 makes 110, and if I subtract that from 180, I will get 70 degrees. So that's what GH, the measure of GH is, okay? So that was kind of the little clue there, was that the diameter is half the circle, which is 180. So there's that. Number 3, this one's kind of a tricky one. The wheels on Elliot's truck, we gotta draw a picture here. The wheels on Elliot's truck have a circumference of 22 inches. Okay, determine the diameter of each wheel to the nearest tenth. Okay, so I want to know the distance all the way across. And the thing that I know is that circumference is the diameter times pi. Okay, that is a formula that you have to memorize for the test. That's one of the first ones. So if you need to put a star by this, formulas to study: circumference is diameter times pi, or 2 pi r. Okay, so that's the first thing that you'll have to memorize for the test for tomorrow. So I'm going to put all the things that you need to remember off to the side over here as we go through this and study, okay? So you can look at that right before you take this test. Diameter times pi, all right? And I know they're giving to me that 22 is the diameter, and then all I have to do, 22 is the circumference, so all I would have to do is divide by pi to get the diameter. And make sure you're using the pi button when you calculate this and not using 3.14, because it will be off ever so slightly. Okay, if you divide, I get that the diameter is 7.003, but they want nearest tenth, which is 1 decimal place. 7.0 is what that, and that is in inches. Inches is the diameter. Okay, if they wanted the radius, then I would just divide that by 2 to get the radius. Okay, so there's how that works. All right, next we have AB. This little chord right here is what that's called. That's a chord that goes all the way across, or not all, from one end of the circle to the other, and that is 12 units. And then OE, this little chunk right here, is 4, all right? OF is 4 also. They want us to find CF, which is this little bit right here, okay? So the fact that these two are both 4 means that this, if this is 12, then this will also be 12. But if they're only wanting CF, the thing about this is that this is going to be the midpoint, so this would have to be 6, right? If this is the other 6, and then it makes the whole thing of 12. So this little piece that's connecting is connecting to the midpoint of that segment. So 6 centimeters is what CF is going to be. Okay, there there you go. Some of these are just real quick solutions. All right, in circle A, it says CG. This distance right here, I'm going to label him as 5x plus 2, and then GD right here is 7x minus 12. Find x, okay? They are giving this as the radius of the circle, and they're saying that it's perpendicular, which is going to take that chord and split it in exactly in half, so we can set this guy equal to this guy. The fact that that forms a perpendicular means it's going to have to split it in half, and we can just set them equal. So 5x plus 2 equals 7x minus 12, and I can subtract the 5x, and I can add the 12, and I get 14 equals 2x, and divide by 2, and all we have to find was x, and it is 7, and we don't have to plug anything back in, but always check. Always check to make sure. Find x, that's all that we need to do. We don't have to plug back in and solve. Okay? All right, number 6. These are my favorite type of problems. These are the ice cream cone problems, okay? So like I have my ice cream cone here and my circle of ice cream, right? So that means that if my cone on this side is 4, then my cone on this side is 4, right? But then I also have an ice cream cone going over here, branching off this way. If this is 4 and the whole thing is 9, then that means this is 5. I make it look like it doesn't go all the way to the center. That's 4, that's 5, okay? I make it look like there's a huge gap, but it's not. And if that's 5, then this is 5. And here's my little teeny tiny ice cream cone, upside down even. I don't know how that's holding the ice cream, but anyway, 2 and 2 is what that guy is. So they say find the length of EF from here to here. And EF is going to be 7 feet. Is that all I had to find was just EF? Sometimes they'll say find the perimeter, okay? The trick there is that these are all called tangents. So like this bottom side here is a tangent line because he's touching just at that one place. And this place right here where he's touching breaks him into the 4 section and the 5 section. So he is a tangent line. He's like basically brushing the edge of that ice cream and going on to the other side. Same thing here. This is only touching at one spot. It's not going through the circle. It's just touching that one spot. So that circle is just literally touching those 3 places. And making a circle out of it, okay? So that's what the tangent thing is. But 7 feet is just the ice cream cone situation, and there is that, all right? Now we get into some harder ones. Instead of saying find the measure of PQ, because PQ is this guy right here, his measure is 60 degrees. They want to know how long it is from P to Q. So like, what's the length of that little pie crust right there, right? Well, if I were to calculate what the whole distance all the way around is, that's called the circumference, right? And the circumference is 2 times pi times the radius, or the diameter times pi, right? If the radius is 3, then I can plug 3 in here for the radius, and 6 pi would be my circumference, or 6 pi is actually equal to 18.85, let's say, okay? But that would be the whole circle around. I don't want the whole circle around. I just want this little bit of it, okay? And the fraction of the circle that this is 60 degrees out of the whole 360, right? So this is the fraction of the circle that I want. I take the circumference and I take it times the fraction. Just 60 out of 360, okay? And if I do that, I just take that same number in my calculator times 60, and I can divide by 360, and I get, hey, look at that, 3.14. They went to the nearest hundredth, which is 2 decimal places, so 3.14 meters, which is pi, technically. Like the extended decimal out, 3.14 is pi. And the fraction of the circle, this technically reduces to 1/6. So you can reduce it if you want to, but you don't have to when you do your calculations, because we're not going to leave it in 60 over 360 form. So there is that 3.14 meters, and that's the length of from here to here. 3.14 meters. Now, always check to see if that seems reasonable, because we're looking at like the distance from here to here is 3. So the distance from here to here, would that make sense to be a little bit more than that? Well, it's curved, so yeah, it probably is going to be a little bit more of a distance. So yeah, that makes sense to me. 3.14 meters, okay? All right, next one, 8. DE. It says DE bisects AB. And when it says bisects, that means it splits AB exactly in half, okay? AB from here to here, it's separating these two chunks exactly in half. Now, it doesn't separate these two in half. Like, this isn't the same as this, right? But it's separating AB. So this chunk right here will be the same length as that chunk, all right? Those two are separated exactly in half. What is the measure of angle BCE? BCE. Okay, so this guy right here, they want to know what the measure of BCE is, okay? Now we know, I just talked about it before, that if we have a radius here and he's splitting this guy exactly in half, then this has to form a 90-degree angle. It has to be perpendicular. So that's what they're getting at here, that is just 90 degrees, and we're good to go. Okay, that's what your radius does. He makes it perpendicular and he separates them in half, okay? All right, backside. Let's move on. If AB is tangent, do we have any other formulas that we needed? I didn't write this one down. Number 7 might be. So when you find then the length of an arc length, maybe I'll write this down. You take the circumference times the fraction of the circle that you want. Okay, that's how you find the little, like when you're doing a circle and you're finding like this little chunk right here. Okay, that's how you find the arc length. Just circumference times the fraction of the circle. So that might be something that, if you don't already know that, maybe write that down. Otherwise, I think everything else is just kind of pretty straightforward. No other real formulas that you need. Okay, let's go backside here. This one, we're going to have some formulas here. If AB is tangent to circle P at B, so this guy right here is a tangent line. He's just touching at that one spot. He's not going through it like this line is going through it twice. So it's touching it 2 places, right? Like this line right here is touching here and here. But this is a tangent line, okay? This is a secant line. What's happening is they want us to find the measure of angle 1, okay? All right, so 86 degrees is this little arc right there, from there to there, okay? And they want us to find the measure of angle 1, okay? Now, I could do this a couple different ways. This line right here, all of this adds up to be 180 because a straight line is 180 degrees, okay? So what I could do is I could say, okay, if this is 86, then this angle right here, this little guy, has to be half of that, right? And half of that is 43 degrees, okay? So if this is 43 right here, then this angle would have to be 180 minus 43. And that is going to be 137 degrees, okay? So this angle 1 is 137. That's the correct answer. You could do this a little bit differently and say instead, okay, if this is 86 degrees, then the rest of the circle would be 360 minus 86, which is going to be 274, I believe. Yep, 274 degrees. So this arc right here is 274. So if I'm trying to find what this angle is from here to here, it would be half of 274, which is 137. So whichever way your brain thinks about it, I don't care which one you do. You'll get the same answer, or maybe you do both of them so that you can just check your answer. So that's 137. You're going to get the right answer no matter what. As long as you do your calculations correctly, it doesn't matter which direction you think about it, okay? All right, this one, number 10, we have, okay, they want to know the measure of angle ABC, which is this guy right here, okay? Now, this guy, we have kind of a formula here that says that if we know the measure of this arc, whatever this is, and we pull it back like a kind of a bow and arrow, if we pull it back all the way across the circle, if I pull that bow and arrow back all the way across the circle, this guy is going to be half of what this arc right here is, okay, whatever that measure is, okay? Now we can find the measure of that arc. If this is 120 here, and this is 100, that's 220 degrees, and 360 would be the whole thing. So 140, this guy is 140 degrees to make all the way around to be 360. And if I pull him back, that's dividing by 2, so he is going to be 70 degrees, okay? So pulled all the way across the back of the circle is, let's see, the angle is equal to 1/2 of what the arc measures is. And and that's called an inscribed angle. Inscribed angle goes all the way across the back of the circle, like a bow and arrow. You're pulling it all the way back so that this dot right here, this vertex, is touching the back side of the circle. Okay, 11. Okay, now they're asking for this angle right here. So we have that this arc is 122 degrees and this one is 68. So we can't just divide by 2, right, to get that angle, because he's not all the way at the back. If instead it was like coming all the way to the back here and like touching and making kind of that little thing, and he was pulled all the way back here, sure, that angle would be 122 divided by 2, or 61 degrees. But that's not the way it works. He is now intersecting in the middle, and we have to figure out what this angle is. And so since we have 68 on the one side and 122 on the other side, we take the average is what we do. So 122 plus 68, and I divide by 2. Let's see, 122 plus 68 is 190. And if I divide by 2, that is 95 degrees, I believe. Let me check that, make sure. Hold on. Yep. Yep, 95 degrees. So that's what this angle is. Now be careful, because sometimes they will try to trick you and they'll say, what's the measure of this angle now? Well, if this is 95, then these two, this angle here and this angle here, would have to add up to be 180. So you would just have to do that extra little step. Okay, so be careful if I ask you for that one. It's the same process again, but you know, that's just the way that it works. So I'm going to draw a picture, and I'm going to do this. And I'm going to say, if X is here, average the two angles. So you add, I think on the notes I said add and divide by 2. So like you would take this arc and add it to this arc, and you divide by 2. So that's when he's intersecting inside of there. Okay. Now number 12 is going to have where your angle is on the outside. Okay, so they're not intersecting on the inside here like he would, but they're on the outside. And what I do there is, if I have my larger arc here is 100 and my smaller one here is 32, what I do is, I'm going to draw a picture. When he's doing something like this, you subtract and divide by 2. Okay, subtract and divide by 2. So 100 minus 32 divided by 2. 100 minus 32 is 68. And 68 over 2 is 34 degrees. So this angle right there would be 34 degrees. Okay, so that's a subtract divide by 2. This one right here, where you have it touching the circle like that, this is a just divide by 2. I don't know if I wrote that anywhere. Yeah, so just divide by 2 on that value. So like the 274 divided by 2, or the 86, you just divide that by 2. You don't have to add them together, divide by 2 or anything like that. It'll just be divided by 2. Okay. All right, a couple more. We've got 13. They want us to find the length of the radius of the circle with an equation of, okay, now they give me this equation for the circle, and these little pieces of information are going to tell me where the center is. So the center of my circle is going to be not at -3, but at +3 and +2, because we flipped the sign there. So +3, +2 is my center of my circle is there. And it says, and it contains the point 1, 4. 1, 4 is here. So the circle is going around that center, and it's touching this point, and they want me to find the radius, okay? And I can do that by doing the distance formula, okay? So I'm going to write the center next to him, 3, 2. When you're doing the distance formula, you're doing this guy, this squared plus this squared, and this is just your x's, and this is your y's. And we totally cheat when we're doing the distance formula because we never write it out. Like, I want you to try to do as much stuff in your head as you can. So when we're figuring out the number that goes in here, we find the distance between 1 and 3. So 1 and 3 would be 2 units apart. 4 and 2 is also 2 units apart. So 2 squared is 4. 2 squared is another 4. And if I add those together, that is 8. And so the square root of 8 is going to be my radius. Now you could give it to me as a decimal, but I'm just going to leave it as a square root of 8, because if they want me then to plug it into the equation, I would just square that value. Whoa, whoa, whoa. I would just square that value and it would just become 8 into the equation. Okay, we've talked about that before. So the square root of 8 is going to be my radius. That's what they're wanting for that. Okay. All right, write the equation of a circle with a radius of 10 and a center at -4, -9. So we go x plus or minus something squared plus y plus or minus something squared equals the radius squared, okay? And this is kind of like a squared plus b squared equals c squared, kind of like that type of thing. So a lot of people get confused whether this is a plus or a minus. That's how you can kind of remember, is it a squared plus b squared equals c squared, okay? So your x value was -4, which means I have to flip the sign, and it's going to become +4. This becomes +9, and then r squared is 100, and this is the equation of my circle. So that's it. Don't forget your squareds. A lot of people forget to put those guys in their formulas. So, all right, here, last one. We need to know the radius, and we need to know the center, and I can figure that out from here. Not that. Center. The center, I look at these two numbers, and I flip the signs, so it's going to be at -1, +2, and the radius is the square root of this number, which is 4. So I'm going to go to -1, +2, and I'm a bad drawer. I'm going to go, since the radius is 4, I'm going to go 4 units in each direction. So 1, 2, 4, put a dot. 1, 2, 3, 4, put a dot. 1, 2, 3, 4, and 1, 2, 3, 4. Okay, and then I'm just going to map my circle around. Ooh, this is really bad. Oh, try to do better than me. Maybe I can get the thing to do it for me. I bet you I can. If I hold my cursor down, I get to cheat. I get to cheat. Watch this. Boom, there it goes. Okay, cool. So, it's still not quite the right spot, but anyway. So, there you go. There's your circle. They just want you to graph it. You'll have to find these things first from the equation, all right? So, maybe that's another thing that you want to try to remember is the equation of a circle, x minus h squared plus y minus k squared equals r squared. Remember that for that, and all of these other circle things that you might need to know. Study those before you take the test tomorrow, and you'll be good to go.